What he did was he came in there and it was a two-tanker. It was a truck with two tanks on it. And he said it was running really crummy. And so it seemed like the injectors were about clogged and all this kind of stuff. And so I worked on it and did this, that, and the other and cleaned the injector and everything. And it ran better. And then he took it, make that noise go away. But he took that thing and he basically brought it back, and he said it's running bad again. And when I got up there and I felt the fuel coming out on my fingers when I was hooking the fuel pressure gauge up, the fuel was stinking like rotten gas. And I said, and I got to investigating that, and that guy had a bunch of rotten gas in his back tank. And he would, whenever it was leaving, it was running on the front tank, and then he would switch it to the back tank so it would run bad, to try to get us to give us the money back for the work we did. And I said, that back tank has got rotten gas in it. And what are you doing here? He says, well, I put some good gas in there with it. I said, okay, I got a half a gallon of sour milk at home. I'm going to pour some good milk in there with it. And that's going to fix it, you think? I don't believe so. I said,
when you told him that?
Well, he got angry and wanted to guarantee that whatever the next thing we did was going to fix it, or we weren't going to charge for it. And so the service manager, I told him what was going on, and he says, I tell you what, the best thing for us to do is just not charge you for anything else and send you to another shop and let you bother them. So he just got a little huffy about that. Our driveline test is right here. Which test is it? Test what? 11, 12? 10. Okay, driveline test 10. Drivetrain test 10.
Sam had to get pretty angry with a customer yesterday.
Yeah, let me see your test.
This man come in there and we put brake pads on and we had to buy them from Advance,
Right.
And over the weekend, Advance come out with a sales paper.
Uh-oh.
And they were like $6 cheaper. He wanted his money back because we sold him pads that were too expensive.
Yeah. Well, obviously.
That's stupid.
Yeah, it really is.
They weren't on sale when we bought them.
Yeah.
And
was that after they went on sale, he wants to come in here and give you a hard time.
Exactly.
Yeah. That's bad news. I always hate it when somebody does something like that. Yeah. What's their problem anyway?
Ridiculous.
Yeah. All
right. Like Black Friday.
Yeah.
You think you're going to go to Black Friday sale was Friday, and you're going to go Saturday and get everything?
Yeah. All right. Now then, it's time for us to do this stuff. We're going to have we got some questions here we got to answer. And I'm going to take just a second to look at this. Generic electronic module. Does anybody know what that is?
Nope.
Generic electronic module. That is basically like the body computer of a Ford. See what I mean? And so you guys lay your phones down and pay attention. All right. And right here we're talking about driveline stuff. And I think that I've got a couple of transfer cases over there. And so we're going to have the opportunity to rip some transfer cases apart, put them back together. Good stuff, right? This particular one. The generic electronic module, it does other things. It basically, the lower end version of this thing that they put on like our Ranger that we've got here for a trainer, they call it a central timer module. Everything that's timed on there goes through this box. If you turn on your wipers on interval and it has to have these timed sweeps for interval, that goes through that box. And if you've got anything that comes on, and stays on a certain amount of time, goes off like one of your warning lights or whatever, it goes through there. It also gets inputs from your door jar switches and operates your, lights and all, and turns on your door jar light. Something else it does, it looks at vehicle speed, and if you hit about 30 miles an hour and it is reading that the door is open, it says they're not stupid enough to be driving with the door open. I know something's wrong, and it shuts the lights down at 30 miles an hour. Been doing that for a long time. They have to use logic on this sort of stuff, you see. And so there's other stuff that's timed too that it handles, like your accessory delay function. If the truck or vehicle has that, you know what that is. Everybody know what accessory delay is? That's what everybody's done this. You just had never thought of it with this name. As a matter of fact, General Motors got a different name for it. Accessory delay is whenever you park the car, you switch it off, and your radio is still working, your windows are working for a little bit. Open the door, and they all die. That is accessory delay. But you've also got your battery saver function. Now, your General Motors, incidentally, calls that retained accessory power. Yeah, they call it. But see, Ford's module that controls your anti-theft and your keyless entry and all that is called a RAP module.
Oh, a RAP?
Yeah, remote anti-theft personality is what that stands for. The General Motors RAP module stands for retained accessory power. So they're both using RAP for an acronym, but one of them is standing for retained accessory power, which, and the other one's standing for, remote anti-theft personality. Anyway, the generic module, it puts a bunch of stuff together. It got vehicle inputs, but it controls transfer case shift operation based on inputs received. Now, that's the generic electronic module, is the higher end version of the central timer module.
Why do they call it generic?
Just because you can use it for so many different things. It does a lot of different jobs. Now, in your Aerostars and stuff, they had they would have a module that was in the back that would take inputs from your fuel sensor. In other words, you had a rear electronic module called a REM and a front electronic module called a FEM. And those two modules, all of the lights, the gas gauge information coming from the tank and all came through that back module and was multiplexed up front. So your front electronic module controlled all the lights on the front of the vehicle. The rear electronic module controlled all the lights on the back. So they're all computer controlled. And it's just crazy stuff. Now, whenever the gas gauge goes bad, if it just opened up or somebody cut the wire or whatever, it would just leave that needle wherever it was the last time it saw a good reading. And it causes people to run out of gas. But anyway, all right, so one way or another, let's walk here and look at, oh my goodness, look at all this. Look at all these inputs. Now, see how many of these inputs you can recognize. See that? How many inputs can you recognize? I'm going to flip that back. I'm just going to go ahead and break precedent and look at our screen. How about that? All right. You got that? Okay, right here. Does anybody know what that is? Let's just start with some of the stuff that we can recognize. What is that? Anybody got any idea what that is? What is this?
It's a four-wheel drive switch.
That's a four-wheel drive switch. What is that?
Looks like a speed sensor.
Speed sensor, yeah. What about this?
Electronic link up?
No, what electronic link up? What a generic term that is. Okay,
I don't know.
this is a, and incidentally, I got to give Ford Motor Company credit for this.
Number two is a digital transmission, a range sensor.
No, well that is.
Yeah.
Number two is. What is that?
I don't know what that is.
Throttle position sensor. Right?
How do they expect you to say that's a throttle position sensor?
Well, that's because you can recognize it if you're half a mechanic.
Ow.
Well, if you've seen one before, you'll know.
I've seen
I got one right over there. I mean, it laying here. But if you've seen, if you're used to working on those kind of cars. Now, this one right here doesn't have exactly the same configuration. But see, that's what you're looking at right there, except the connector's coming off at an angle. See that?
How many of them do you see with the connector coming off at an angle?
Not very many, but I mean, that one there, they wanted to make sure you knew where the wires went to, I guess. It made it easier to identify to see this oval-shaped hole here in it, and that connector comes off. Anyway, that's the throttle position sensor. What is that?
I don't know.
That is the brake, the boom sensor, brake on off. That's your stoplight switch.
Oh, okay.
Yeah, that's what that is. Now, what is that?
I don't know. Looks like a tungsten.
Now, there's a legend down here. We're going to look up under here.
Looks like some kind of temperature sensor.
Yeah. All right, now, do we know what this is? That's a couple of vacuum solenoids, isn't it? Right?
You say so.
All right, well, that's what it is. You see the vacuum lines going to them, the wires? And look at this right here. What is that?
It looks like it's matter.
That is a module of some kind, isn't it? So we're gonna look and make sure that we know four-wheel drive, automatic four-wheel drive high, four-wheel drive low. All right, now let's see how many of those we bombed on. Okay.
All of them.
We got to do some of them. All right. Inputs and outputs, right? Well, let's see what we got here. All right. Now then, which one were we foggy about?
All of them.
We got there. Shift motor sense plate, right there. See that? All right. That's a shift motor sense plate. Now, what else were we confused about? 8, clutch pedal position sensor. Now that's going to be difficult to recognize, isn't it?
Yeah.
All right. Now then, Now you got your four-wheel drive motor switch. What else were we worried about? We knew about all of these on this side now. But look at 3 and 5. 3 and 5 are interesting.
I don't know what you.
3 and 5, front output shaft speed sensor, and 5 is rear output shaft speed sensor.
They look alike, but
They are because they're both sensing shaft speeds. So you're going to use the same sensor in both of them. And on a automatic four-wheel drive, if it determines that you've got some wheels spinning, it automatically throws it in four-wheel drive. I mean, you don't have to do nothing. You're just driving, and you're driving, and when it quits spinning, it uncouples them out of there. Cool stuff, huh? All right. Now then, what do you got up here on the? Let's look at 11. What's number 11? Number 11 is a funky module. All right, let's look at 11. 11 is the electric shift motor relay module. And then right here, we're on number 12, is going to be vacuum shift solenoid. We talked about that. And 13 is a torque on demand relay. Well, look at number 10. Number 10 is a generic electronic module. There it is, right? I've got some of them laying around here. I mean, there's a plastic module. Sometimes it piggybacks on the back of the fuse panel, and sometimes it's mounted by itself and all that. So now there's only 16 pages of this handout, so it's not like the 51 page when they went through yesterday. All right. Okay. Now you got your electric shift motor right there, and I've got actually one of those mounted on a board over there, so you can operate that shift motor and watch the different lights light up and all that. Pretty cool. It's like a glorified wiper motor. You know, a wiper motor's got little contacts in there to tell you when you're in park and all this. Well, this one's got little contacts and plates and stuff so it knows what gear it's in. Like that. And it actually talks back to the module. I mean, the module is watching those inputs and it knows where it's at. All right, you got a rotary cam, moves the shift fork. See how that goes? All right, got it located at the rear of the case. You got a shift motor sense plate. Once again, this is a Ford Motor Company public domain handout, and so, you know, and I wrote a test around it. There's your 4x4 shift motor relay. It's in there, you know, they're pointing it pretty much where it is. Got 2 solid state relays controlled by the GEM, controls power to the shift motor between the transfer case modes. Now, the cool thing about that is if you're ever monitoring the operation of these things, when you tell it to change, you're going to see those relays go click, 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 click. It's interesting how they do that. Dun, 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 dun. Now, they used to have a standalone module that was just for shift on the fly four-wheel drive before they had the GEM. And it was over there on the right side, had a little heat sink in it. You know, and when they were working right, I'd get down there. And a lot of the times, what you can do is, this is important. Now, you unhook your transfer case motor from your transfer case. You just unhook it, let it hang by the wires. And then you tell it that you want it to go into various different places by turning your knob. And you watch that little sucker and see if it turns.
Right.
You know, it's not
so basically, only thing they did when they had separate modules, they got smarter and decided to put them all together.
Yeah, they basically rolled it into this GEM module because it made it easier for them to do that.
Right.
The one screwball, the Crown Victoria has got the lighting control module on the Crown Victoria that's right above your right shin in the car. It controls all the lights and the horn and all kinds of crazy other stuff. And that is the one, and almost some of your Lincolns, they have that too, the cars. But it will, it actually controls all kinds of stuff you would never associate with it, like the trunk release and stuff is controlled by that. Huh. And, you know, and you can actually, what's really screwy is whenever you're pulling the fuses out, you know, when you're pulling the fuses out, you'll pull the fuses out and you'll get to a particular fuse, and when you pull it out, the horn will go honk. And you're saying, whoa, something's wrong here. All right, but anyway, let's go on again with this thing.
Why would they have to have all that go through there?
Well, they basically, you can. It's pretty cool because you can talk to it with the scan tool.
Right,
you can look at your inputs and outputs. When they used to have just modules that a scan tool wouldn't talk to, that was a booger bear.
Yeah.
All right, now right here.
So basically what they wanted to do is where you could talk to it.
They wanted you to be able to have a window into the system where you could just plug in and it would actually have communication with the tool.
Right.
And you can say, as a matter of fact, some of the anti-theft stuff on those Jeeps will tell you what it was that caused the theft system to light off the last time it happened. That's cool as all get out, because they say, hey, any theft went to honking horns and blowing horns and flashing lights and all, and I don't know what caused it. And so you plug your scan tool in, it'll say last theft activation was the hatch release. You know, the hatch switch. And so, now I can forget about the hood, the doors, and all this other stuff and concentrate on that.
Right.
And check that circuit and maybe look at see if the switch is trying to stick a little or whatever. Now, all right. Now these are sent to the front and rear output shaft speeders. They're going to sense tone wheels on the front output shaft and rear, and they're sent to the gym and indicate front and rear output shaft speed. So, in automatic four-wheel drive, when it senses the difference between the output shaft speeds, the clutch coil duty cycle is increased until the output shafts are turning at the same speed. Is that cool? It keeps putting more and more current into that clutch coil inside the transfer case, letting those things gain speed until they're both turning at the same speed. It's kind of like an electric synchronizer. That's neat, isn't it? All right, and there's your clutch coil assembly. It's controlled through the torque on-demand relay. Pulls the armature against the cam coil housing assembly, located inside the transfer case, and it's power side switched. What does that mean? What does power side switched mean? What's that term mean right there?
I don't know.
That means that it's not switching. It's not. No, it's switching. The switch is on the ground on the hot wire, not on the ground. Now the interesting thing about these things, you always kind of have an idea. We got used to for years, like it switches the ground side of the injectors. They're always wired to power. It switches the ground side of those. The air springs on the suspension system, it switches the hot side of those, which is sort of antithetical to most of us guys that fought with the fuel injection and stuff for all those years are used to watching ground side switch. In your 4EAT automatic transaxle or in the Nissan RE401A, the transmission solenoids are hot side switched. I mean, there's the positive side of them that's being switched off and on. Now, we were told every time I went to electrical school, every time I went to, when I worked in a different franchise or we bought a different franchise or whatever, I went to electrical school with like Mazda and Volkswagen and Chrysler and Ford and everybody. What they always would tell us was they usually switch the ground side because you got less arcing switching the ground side than you do switching the hot side. There's less likely to burn switches and all that kind of stuff. But I mean, if you put a capacitor in there to catch that arc, it's not going to matter anyway. But the simple fact is, you need to know which side is switched. I mean, you really do. Yeah. If you're going to be working on this stuff. Is it the power side or is it the ground side? So
basically what you're saying is it's always got a ground.
And it's switching the power off and on. That's what it's doing. Instead of having it always hot wired to power and all that. So that's.
I mean, I don't understand why they do that. I mean,
huh? I don't. Well, there's a reason for it. Maybe because of the speed that it works, or they got some polarity issue or something. I don't know. But they're the ones that made the decision. Right. And all you got to do, if you don't want like for instance, in the points in our distributors, in our ignition systems here, if those things, if you didn't have that condenser in there, they would just burn the points up real quick because they make a spark. But because of the fact you got that capacitor wired in there, it's going to let that spark that's trying to jump across the gap. When you break the gap, the connection wants to stay there. The electrons want to keep flowing, and they, But if they've got somewhere else they can go, they're going to head that way. So they go into the condenser and they charge up that condenser. And when your points close back up, that immediately screams back into the coil and charges it up a lot hotter than it would be without that condenser.
So basically, with the points, the leftover spark is.
Well, actually, the spark, whenever you close the points, what are you doing? You're saturating the ignition coil.
Right.
Whenever you open the points, that field collapses, and that's what makes your spark. Okay, so as you're breaking those points, and that anytime you break points or flip a switch or anything, if there's power flowing through that switch, that power is going to try to keep flowing even across that air gap for a little bit until it gets to where it can't. The higher the voltage, the more it is. But you've got on the points when you're doing this making and breaking, that's 400 volts that has been generated. So when you break the points, that 400 volts it wants to try to keep jumping across that gap, and it's going to transfer that material from the points and ruin them. Unless, like I say, you put with that condenser that's in the distributor, and you won't get very much of a spark at all without condenser. You put that condenser in the distributor, which is like a capacitor, it's going to gobble up the spark that's trying to jump across those points, going to go right into that, and then it's going to, like I say, when they close again, that what was stored in there whenever this points were breaking zooms right back into the coil and charges it up and saturates it that much quicker, and so it just works real smooth like that. But anyway, I sort of got deeper into that than I meant to, but it was, oh well. All right. torque on demand relay, and when it activates the solid state relay, what's solid state mean? No moving parts. It's got transistors and diodes and stuff in it. You know what I'm saying?
Solid state
Right.
hard drive.
Huh?
Like a solid state hard drive.
Yeah, solid state hard drive doesn't have any moving parts. It's just like a jump drive. You know, it's also very expensive. And until they, you know, until Windows 7 came out, the more you used a solid state hard drive, the more it would deteriorate.
Really?
Yeah. In other words, it would get to where it was not. It's not like, you know, reformatting the drive. You know, it's hard to explain, but the file structure gets all distorted. Believe me, I've been there. Okay, but Windows 7 has got a utility for keeping that from happening. That's why I put Windows 7 Ultimate on my little small netbook. You know. All right. Anyway, what is that part right there again?
This is your transmission range.
Transmission range sensor. All right. Now there's two different types, right? This one's the one we're talking about today is digital. Now, what's the difference between a digital transmission range sensor and an analog transmission range sensor?
On the digital, the waves would be all like kind of blocky and just.
Well, you're
it's just
close.
on or off.
You're kind of close, but basically, a digital has got 4 switches, and they're either off or on. And different ones of them are off or on based on what year you're in. And so, but you got a 4-part binary code, right? Now you understand binary math, right?
Somewhat.
Don't worry, you will. We learned that in automotive. Did you learn something about that? You did. You remember how it was working?
1, 0, 1.
Yeah. Do you want to get up here on
Alright,
YouTube
yeah,
and
I
explain
will.
it? I don't think so. All right. But I'm not going to go into all that right now because we get into that when we're in automotive electronics. But the long and the short of it is a throttle position sensor can read anywhere between like, you know, just below 1 volt up to about 4.5, right? Anywhere in between there. The analog sensor has basically got 3 wires going to it. One of them is reference voltage, one of them is signal return, and one of them is your signal wire. And that voltage goes up in steps as you're changing. And those sensors wear out. So if you happen to scope it, I know Michael's got a scope.
Yeah, his skin.
If you hook a scope, well, yeah, his scan tool probably got one built in it, yeah. But you take that scope and you hook it into that signal wire, and you actually click through your gears, you're going to see stair steps on your scope screen. And if any of them drops out, you got a bad one, and those things can cause issues. So you need to make sure you got a good, clean signal. But on the digital one, you're going to see they're switching off and on. Like you may see switch 1 and 2 may be on, and switch 3 and 4 may be off. And there's, you know, in your mind and in my mind, we're thinking, well, what we would do is we would have 4 switches, and for each one, we would close another switch in order. Wrong. Transmission solenoids and digital transmission range sensors do not operate according to the kind of logic we have. Like if I was going to have a transmission that was going to have shift solenoids 1, 2, and 3, and it was a 4-speed transmission, I would let it start off with none of the solenoids energized, and I would let it go from first to second. And when it shifted to second gear, I would have shift solenoid A or 1 energized, and that would throw it into second gear. And then I'd have shift solenoid 2 energized, that would throw it into third gear, and then shift solenoid 3 would, they're all over the place. They're all out of order and everything else. You got to know what's normal, but you cannot logically say, okay, when I see shift solenoid 1 energized, I'm going from first to second. That ain't the way it is. You got to have charts for that. But these sensors, and there's on our automatic transmission, some of you guys went through that worksheet where you hooked up and you measured the voltage on every one of these, and you found out which one of those switches were closed in which gear's position. Chelsea hasn't been through that. But that's what that does. There's 4 switches that open and close, basically. You know, like dip switches? Hey, there's our aquarium. How about that? All right. Now then. Hello. I typed the wrong password in. All right here. Now watch.
All right, hold on. There's an answer to this.
Okay, you see anything there? You got a question there, right? What's your question?
Determine when the transmission is in neutral.
All right. Let's look at this for right here. Well, we're going to have to go in there. You're going to be reading these questions as we go, see, and pay attention. Because we've only got 10 questions here. And we've only got 16 pages.
Wait, what text was that you were just looking at?
What's your first question?
First
Vacuum control solenoids are controlled by PCM.
Well, that may be a different test.
Yeah.
Yeah. Oh, I'm sorry, that's 11. That's the next test. That's the wrong one. Not a big deal. You're still going to get your answers for this test. This is the right test. Yeah, this is the right test for this answer, but the answer key that I had pulled up was the wrong one. That ain't a big deal. You shall not surely die. All right. Okay, now right here. The digital transmission range sensor sends a signal to the GEM from transmission shift position. The GEM uses that signal to determine when the transmission is in the neutral position to allow the transfer case to shift into or out of four-wheel drive low, and it's located in the manual lever on the left side of the transmission. On some of these newer vehicles, the transmission computer actually looks like a neutral safety switch.
Really?
Yeah, it's a complicated little machine that's right down there.
Little bitty thing.
Yeah, it's not very big. It's about this big, and it's got little cooling fins on it and stuff. The throttle position sensor signal is sent to the GEM, and they use that information to increase clutch coil duty cycle under heavy throttle or off throttle with a vehicle speed above 30 miles an hour. Got that? It's used in automatic four-wheel drive GEM strategy on some vehicle lists. I cannot believe that they made an error. A spelling error on this Ford Motor Company public domain handout. All right. Right here, we got clutch pedal position switch. Only used on manual transmission vehicles. Why is that?
Because it only has an on that transmission.
You don't have a clutch pedal on the other ones, do you? It's used as an input to allow the engagement or disengagement of the four-wheel drive low position. So you got to have your clutch mashed or you got to have it in neutral, depending on whether you got an automatic or a standard. And it's located on the clutch pedal bracket. Now here we go. Brake pedal position switch. Used as an input to allow the engagement. Located on the clutch. You know, that's all about going into four-wheel low. You don't want to shift it into four-wheel low when there's a possibility that you might absolutely just ruin everything when it goes in there, right?
I know somebody that put it full low and swung every single one of the rods outside the block.
Just destroy it.
Everything.
Yeah, but what we were, I had this one guy that we had that was working, actually doing some advertising for the Ford place over there. He was driving, and this was back in 1986 when Bronco 2s were all over the place. He was driving a brand spanking new Bronco 2, and it was a 5-speed. 1, 2, 3, 4, 5. Reverse is over here opposite fifth, right? And so he was goofy enough and just wasn't thinking, I don't guess. And he's driving down the road. Well, actually, the way it came about was, he's driving down the highway, and he gets into fifth gear, and for some reason, he's confused and he thinks he's got another gear left to go. And so he brings it all the way back into reverse. And somehow he manages to get that thing in reverse. Well, you know what it did? All the little teeth on the synchronizer, it just sheared them off. And so, and it did, apparently it must have done this really quick and really clean. And so they gave me the ticket, and I says, because I was doing transmissions in, and he says, this thing's got no reverse. And I'm thinking, what? A brand new vehicle with no reverse? Now you put it in reverse, it made no noise. It didn't go backwards or anything. So where's reverse at?
Back
On that one, very back. And I pulled the extension housing, I pulled the drive shaft. It wasn't four-wheel drive, it was just a two-wheel drive. I pulled the extension housing off, and when I got back there, all of those little teeth off of that thing were just laying in a little pile down in the bottom. And basically I just had to order that one gear and put it on there, and he had reverse again. It just slick as a button. But that's the craziest thing I've ever seen, how he managed to slide that thing in. It seemed like it would grind, but apparently he went in there quick enough to where it just happened to drop in just right, and it was boom. And when it did that, all of a sudden it wouldn't back up. Now it was obvious to me what he did, but he wouldn't admit to it. All right, now you look at this. Look at your vehicle
Did
speed
you get it
signal.
fixed for free?
It was a warranty job, and the car was a demo that belonged to the dealership. See, so it didn't hardly have but about 3,000 miles on
My
it.
cousin done that one time, and it locked in reverse, and it, boom,
Yeah.
snatched him back around, and the whole truck just started spinning. He was going like 55 miles an hour. He says, I swear, I was behind him, and I seen.
Yes, he was going around. That's scary as all get out when you see something go south. I was riding behind this friend of mine on a Dodge pickup that was just like Brandon's, and I saw, or similar to Brandon's if it was older, and I saw a tie rod end came apart. one of the wheels started doing the shopping cart thing, like that. And man, he's all over the road. He's off the side of the road. He's in this other lane. He's back, and finally, when he got, and the back of the truck was doing this because it was, it was horrible. And if it had been a truck coming, it would have been over for him, man, or anything, you know, any kind of. So anyway, he went up off the side of the road, and they went ahead and I loaned him my pickup so that he could go and get parts to fix his pickup truck, and he burned a bunch of gas out of my pickup. I didn't get anything out of it. Well, gas went about 40 cents a gallon that day anyway. All right here we got speed sensor control module. Or, and that'll be hardwired, see, sometimes. And then sometimes you got speed sensor, other module, and control module. So the other module, and an example of that would be your speed sensor would be that sensor in the rear end on those Fords. It would send to the ABS module because it's hardwired. The speed sensor is typically hardwired to the ABS module, or it was for years. And the ABS module would send it to other places. Now, where else does the vehicle speed information go besides the GEM module? PCM, speedometer, you know, cruise control, this kind of stuff. Yeah. Okay, so you got this thing right here. You got a speed sensor, other module hooked up to the network, and all these other modules here can actually use that information if they need it. It's available in all of them, but the only ones that need it are the ones that tap into it. And then there's your control module for your your GEM module, whatever. So anyway, that's just the way all that kind of stuff works. So it basically that slide there that basically require a lot of verbiage. Now look at this. This is pretty important little diagram right here. What are you seeing right here? Somebody tell me what we got. These are numbered. What is this?
Fuse.
That's a fuse. So we got a fuse, and it's feeding power to this solenoid, and it's feeding power to that solenoid. The other wire from that solenoid is going to what?
Ground.
No, wait a minute. It's going to ground through what? You going to ground the solenoid all the time? What the sound? How good is that? Don't you need to control that? Switch it off and on? So what's this box right here? That's going to be your GEM module. All right. So now what's this? This is actually vacuum, right? All right. So you got vacuum there. You got a check valve. See that check valve? That vacuum check valve is going to let you build vacuum. What's this right here? That is a reservoir. You know the little, on some of the, like on the big Bronco out here, we got this syrup can looking thing over on the side. Or you'll have or like a high C can. That's actually a vacuum reservoir because it's good and solid. And it's got these little nipples sticking out the end of it that actually one of them comes from your vacuum source and the other one feeds whatever's being fed. See? And that's so when you go all the way to the pedal, your vacuum goes away, you still got some vacuum to do the work. That's what that's for. But that reservoir is going to capture your vacuum. This is a schematic. All right, now it's feeding vacuum to these solenoids all the time. See that vacuum on the solenoids? All right, when this solenoid is energized, what's going to happen here? It's going to go to this actuator, right? But what happens when you put vacuum there? Now, what's not drawn here, what you don't realize is typically the way these solenoids work, most of the time when you see solenoids like this, if it's not energized, it's vented to the atmosphere. And I'm not talking about vacuum being vented to the atmosphere. I'm talking about the control component is vented to the atmosphere. So if this one here is not energized, you got atmospheric pressure right here. If you put vacuum to that side of it, it's going to move that rod that way. If you put vacuum to the other side, it's going to move it that way. And so that's how that's going to be working. Now look down here at the vacuum control systems. See if we write about all that. Got your GEM module, got your vacuum line, shift motor, manual shift lever. Number 5 is right there. Yeah, that's actually the thing that's being driven. All right, two-wheel drive vacuum solenoid, vacuum reservoir, check valve. Hey, there you go. We're fixed up. All right, you got indicator lights, 4-wheel drive high and 4-wheel drive low. Remember what I told you about that? The PCM needs to know when you're 4-wheel low. Why? Why does it need to know when you're 4-wheel low? Doesn't it need to shift into the next gear a little lower at a lower vehicle speed?
Yes.
All right, so you're thinking about that too. All right. Okay, so output of the GEM on this one though. On the older ones, we actually had a grounding switch. We'd have power going to that light, fed by the fuse panel, and we'd actually have the grounding switch built into the transfer case, and then it would actually turn that light on when you put it in. On this one, the GEM module is actually going to illuminate that light. It illuminates when and you can talk to it with a scan tool, right? Illuminate it when the transfer case is in all-wheel drive. See, it'll tell you automatic four-wheel drive, if it's gone into four-wheel drive, it lets you know.
That's about the
It flashes when the gym senses a fault. You got that? You understand this? If you see that light flashing, you know you got an indicator and you got a fault. All right, that's your actually just the automatic four-wheel drive indicator light, and it's on the right side of the cluster. All right, you got your four-wheel drive high. That's also an output of the gym, and it's located on the right side of the instrument cluster. And then there's your four-wheel low, and it's located on the right-hand side of the instrument cluster, which is not too complicated. That's the last page, guys. What do you think about that? That was a short handout, and we're gonna have to track all those answers and everything. Huh? You got it? All right.